The cosmos is a vast, dark ocean, and we are just beginning to explore its depths. In late 2023, astronomers spotted something extraordinary, a faint, slow-moving point of light in the Kuiper belt. This wasn't just another asteroid, it was different. They called it 2023 KQ-14, but soon it was nicknamed Ammonite. Like the spiral fossils on Earth, Ammonite promised to be a relic from a lost era. Its discovery electrified astronomers. The Kuiper belt is our solar system's attic, filled with ancient leftovers from its formation. Each object out there is a time capsule, but Ammonite stood out. Its existence hinted at a story that could challenge our understanding of the solar system's structure. Imagine a team of astronomers scanning telescope data, searching for anything that moves. Suddenly, a tiny dot shifts position, a new discovery. More data is gathered, its path calculated, and the object's true nature emerges. The thrill isn't just in finding something new but in the questions it raises. Ammonite became a cosmic question mark, forcing us to rethink what we know. Science advances not just with big breakthroughs but with outliers like Ammonite that don't fit the model. It's like finding a fossil where it shouldn't exist. Such discoveries force us to re-examine our assumptions and rebuild our theories. Ammonite isn't just a rock in space, it's a catalyst for new ideas. It challenges us to look deeper and think bigger about our place in the universe. The adventure of discovery is just beginning. What is Ammonite exactly? Let's take a closer look. Based on its faint light and distance, Ammonite is about 400 kilometers wide, big, but not a dwarf planet. It's likely an irregular lumpy worldlet, a planetary building block that never became a planet. Its surface is a frozen mix of water, methane and nitrogen, unchanged for billions of years, but its orbit is what truly astonishes astronomers. Ammonite follows a highly eccentric path, swinging from 45 AU at its closest to over 1,200 AU at its farthest. One trip around the Sun takes more than 13,000 years. This makes Ammonite a fossil, untouched by the chaos of the inner solar system. Its composition and orbit preserve a record of the early solar system. Studying Ammonite is like unearthing an ancient artifact, offering clues to a time we can barely imagine. For millennia, it drifts through the cold, dark outskirts, the sun just a bright star in its sky. Its isolation has preserved it, deep frozen and unchanged. The elongated orbit is a scar, a sign of a powerful event long ago. Ammonite is a key witness in a cosmic detective story. Its secrets could reshape our understanding of the solar system's past. Ammonite isn't alone, it's part of a mysterious group called Sednoids. Sednoids like Sedna and a handful of others have extreme detached orbits far beyond Neptune. They're incredibly hard to find, small, dark and moving slowly against the stars. Only a few are known, each a rare clue to the forces shaping the solar system's edge. Their orbits can't be explained by the known planets alone. Sednoids are too far for Neptune's gravity to reach, yet they didn't form so far out. Something must have kicked them into these strange orbits. They're like boats adrift in the ocean, far from any harbor. What force set them loose? Their orbits hint at a powerful, unseen influence, past or present. Each new Sednoid adds a piece to the puzzle. Ammonite, the latest, brings a clue that complicates the story. The mystery of their origins is far from solved. Every new Sednoid is exciting, but Ammonite is unique. Most Sednoids have orbits pointing in the same direction, as if shaped by a single force. This alignment is the main evidence for the hypothetical Planet 9. But Ammonite's orbit is different. It's tilted almost 90 degrees from the others. If the other Sednoids are a flock, Ammonite is flying solo. This misalignment challenges the Planet 9 theory. If a giant planet shaped these orbits, why is Ammonite so different? Maybe the story is more complex, perhaps multiple events shaped the outer solar system. Ammonite doesn't fit the simple narrative. Science thrives on such contradictions. A new observation like Ammonite forces us to re-evaluate our theories. Does the theory need tweaking, or do we need a new explanation? Ammonite's path is forcing astronomers to rethink one of the most exciting ideas in planetary science. The Planet 9 hypothesis suggests a massive, unseen planet far beyond Neptune. This world, 5 to 10 times Earth's mass, could explain the clustering of Sednoid orbits. Simulations show its gravity could shepherd these distant objects into alignment over billions of years. For a while, every new Sednoid seemed to fit the pattern, until Ammonite. Ammonite's orbit defies the prediction, standing apart from the cluster. If Planet 9 exists as theorized, Ammonite shouldn't be an outlier. This contradiction weakens the case for Planet 9. Maybe the model is incomplete, or maybe another force is at work. Science isn't black and white, sometimes evidence points in new directions. Ammonite's discovery has scientists searching for alternative explanations. The shadow of Planet 9 is less certain now. The hunt continues, but the mystery has deepened. The list of suspects is growing. If not Planet 9, what else could have shaped these orbits? One idea: a close encounter with another star in the Sun's birth cluster billions of years ago. A stellar flyby could have scattered objects like Ammonite into eccentric orbits. Different encounters could explain the variety of Sednoid paths. Another possibility: a rogue planet passed through the solar system, scattering objects before moving on. Even a Neptune or Earth-sized planet could have had a dramatic effect. Or perhaps the solar system once had an extra planet, ejected after a close encounter. As it left, it could have flung smaller bodies into elongated orbits. The Sednoids may be the last remnants of this lost world. The outer solar system's history is more chaotic than we ever imagined. The debate over Planet 9 and stellar flybys is fascinating, but Ammonite's real value is as a messenger from the dawn of our solar system. It's out there now, silently orbiting in the cold and dark. Ammonite and the other Sednoids are tangible links to our origins. By studying their composition and orbits, we glimpse the solar system's earliest moments. These discoveries push the limits of our technology and curiosity. They remind us our map of the solar system is still incomplete. The Kuiper Belt expanded our view, and now Sednoids reveal an even vaster frontier. What else is hiding in the dark? Ammonite proves there are still major surprises. The outer solar system is dynamic, filled with echoes of ancient events. Each new discovery brings us closer to understanding our cosmic story. Ammonite has challenged theories and inspired new questions. The search continues. The darkness beyond Neptune is not empty. We, the explorers of a small blue dot, will keep looking, because that's what we do, we explore.